No, we're gonna take our flowchart quiz. Probably not even tomorrow. Probably Friday. Okay, we'll probably take our flowchart quiz Friday. Okay. Yeah. We'll talk about it again tomorrow. But so tomorrow we're gonna do tomorrow. All right. So yes. So today we're talking about the limiting reactant. Okay. It could be termed as limiting reactant or limiting reagent. Okay. Limiting reactant or limiting reagent. Your limiting reactant is exactly what it says. It is the reactant that limits the amount of product that can be made. Going back to the beginning of this unit, we talked about how if we had we were going to make some brownies and we need 2 eggs, a cup of milk, and a box of brownie box mix, and we had 10 boxes, 4 eggs, and 8 cups of milk. What limited what we would make, what thing did we use up first? In that case, would have been the eggs, okay? So you would only been able to use 2 boxes of the other reactant. 2 boxes of the other things that react. So that's what the limiting reactant is, okay? Today is really nothing new. It's just twice the amount of work, really. Okay, it's just really twice the amount of work. You're going to figure out what reactant limits the amount of product that can be made. Typically, we've only given you information about one product so far, okay? And you've seen the term a lot. It says it's been mixed with excess of something else, okay? So that's something where we haven't really used it yet. We didn't understand what that meant. Now we'll start to make sense. So your work's still the same. Consider the reaction, diiodine, pencil oxide reacts with carbon monoxide to form carbon dioxide and iodine gas. So, and it should have said, if 80.0 grams of iodine 5 oxide reacts with 28 grams of carbon monoxide, determine the amount of iodine that can be produced. So I've got 2 things I know here, don't I? I know that I have 80 grams of this, correct? And I know I have 28 grams of this. My question mark, what I'm looking for is my grams of iodine, okay? My grams of iodine. So this is still stoichiometry. Our first step to any stoichiometry problem is to do what? Balance chemical equation. Is this balanced? Yes, it gives you coefficients, so it is balanced. So now I'm ready to take what I know and put it over 1. But I know 2 things, don't I? That means I got to do 2 problems. It means I got to do 2 problems. Doesn't matter which one you start with. I'll start with the first thing they give me. So I'm going to take 80.0 grams I2O5, and I'm going to put it over 1. This is a mass to mass, isn't it? Because I'm in grams. I want to go 2 grams. So this is a mass to mass problem. I'm going to multiply. What's going to be in the bottom of this next fraction? What? The molar mass of I2O5, okay? So I need someone to tell me the molar mass of I2O5 on the top of the next fraction. I saw somebody, they worked on this. I was very proud of. They went through and they automatically went in and put all the 4 things they knew was mass to mass. And you can put 1 mole in, this is always going to be 1. Top of this fraction is always going to be 1. And the bottom of the last fraction, if it's mass to mass, always going to be 1 too. Somebody went in and did that. I don't remember who that was. So, anybody got the molar mass of I2O5 for me? 333.805, is that right? What's iodine's atomic mass? 9.4. So you have the wrong number of decimals, is my point there. Yeah, so you get 333.805, so it'd be 333.80 grams I2O5. Okay, we missed a lot on some of the homework that you've missed. For the most part, if you've been missing things on your homework, you've been missing because of significant figures. Okay, because when you're adding and subtracting, you care about decimals. Okay, you need the fewest number of decimals. What's that, 3? Oh, I thought you said they only had 2. 80, so that would have been 805. Let me, I apologize. Let me delete that whole thing down. Well, it's kind of squeezed in there. Release number decimal. So now on the top, I'm going to have 1 mole. On the top, I'm going to have 1 mole I2O5. So now I've gone from mass known to moles known. My grams I2O5 cancel. My grams I2O5 cancel. A lot of you aren't putting those units, and I've talked to you. I think you started doing better with that, okay? So what's going to go in the bottom of this next fraction? Gavin, what's going to go in the bottom of this next fraction? Say it, you were correct. Say it louder. Where'd you get that 1 from, Gavin? The balanced chemical equation. Yes, sir. 1 mole I2O5. And on the top, let's go with Marshall. What? Yes, sir. 1, not just 1. 1 mole I2. 1 mole I2. And mole I2O5 cancel, mole I2O5 cancel, times Brooklyn, what's going to go to the bottom of this fraction? My next fraction. 1 mole I2, because whatever on the top goes on the bottom. And on the top is going to go what? Ben Oliver? Grams I2. That's the molar mass of I2. So mole I2 cancel. And then when you put that in your handy dandy calculator, what do you get? 2. Say that louder. 60.8 grams I2. Great job. All right, so you're not finished yet. Okay, because you've only got to do, when you're talking about, they give you 2 masses, that means, or 2 moles, that means you got to do 2 problems. So now I need to do the other known information I have. My other known information that I have is dealing with what? 28 grams of carbon monoxide. 20, so 28.0 grams CO. And I'm going to put that over 1 times bottom of this fraction, Thomas Murray. Molar mass of CO. So what is molar mass of CO, Thomas Murray? O102? What? And grams CO. That's the molar mass. And on the top of that fraction is going to be what? Ben, not Ben. Zariah Chapel. 1. I need more information there. 1 mole CO. 1 mole CO. That's still my known. So now I'm going to multiply again. My grams CO canceled. My grams CO canceled. What's going on the bottom of this fraction? Ben Whiting, what's going on the bottom of this fraction? No, not 1 mole. What unit's going to be in the bottom of it? What units are on the top of this one? Mole CO. So what's going to be in the bottom of this one? Mole CO. So how many moles of CO do I have? 5. Get that? That's the mole ratio step. So you get that from the balanced chemical equation. So here's the good news, people. Does my unknown change? So the rest of it's identical, isn't it? So I don't have to go find another molar mass. So I know that on the top is going to be 1 mole I2 because, I mean, I can work that out, give my equation, and I know that undo. That didn't work out very well. So I know my last thing, multiply, I'm going to have 1 mole I2 on the bottom. And then 253.808 grams I2 on the top. Somebody gave me. Yes, Anaya? So what's the answer? 50 point what? 50.7, so my mole I2 canceled. 50.7. So I got 50.7 grams I2. So I haven't answered my question yet. Someone answer the question for me. What mass of iodine can be produced? 50.7. The smaller number is the mass that can be produced, okay? So your answer is 50.7. My answer is 50.7 grams of I2. I can ask two other questions to this problem, okay? Right now. What is the limiting reactant or the limiting reagent? What reactant? The limiting reactant is the reactant that limits what I can make. So what reactant gave me the smallest number? What? Carbon monoxide. So I can say carbon monoxide is the limiting reactant, okay? What is the excess reactant? What's left over? What reactant's left over? I2O5. Because if I used up all my CO, what's the only thing that's left? I2O5, okay? Because it's what? It's not the limiting because it's the smallest here, okay? It's the limiting because it gave you the smallest number. Yeah, yes, ma'am. It gave you the smallest number. So CO is the limiting reactant because it gave you the smallest number. Don't assume, and this problem worked out this way, don't assume that because this number is bigger and this number is smaller, that CO is the limiting reactant. It won't always work out like that. The CO2 is just another product. I could have done the same problem to CO2. Okay. I could have done the same. There is no excess product or excess or limiting product. Okay. We're only talking about the reactants here. All right, let's do one more. Let's do another one. Any questions so far? I mean, it's very similar to what we've been doing. Very similar to what we've been doing, but we do have a little bit of new stuff in there. And this one's going to have both questions in that. Give you a second to write it. So in this problem, it gives me now kind of a code, kind of a giveaway that I need to do two problems. It gives me two reactants. I mean, two quantities of reactants. Okay, so that's how I need to do two problems. Now, can I start by talking how much your problem now? Why? It's not balanced. Okay, so how would I balance this one? 818. 818. Right. I'll put a line there for some reason. Oh, I put a 1. Oh, my bad. 818. Okay, 818. All right, so I'm ready to start working this out. What is my unknown? What substance is my unknown? What am I looking for? Zinc sulfide, okay? So does it matter which one you start with, zinc or sulfur? No. I'll start with zinc because that's the first one that's written. There's no wrong answer if you don't. So I have 25.0 grams Zn over 1 times by, on the bottom is going to be the molar mass. What's the molar mass of zinc? 65. What? 65. Did not know that. Grams Zn. And on the top is going to be 1 mole Zn. This is going from mass known to moles known. My next step is the mole ratio step. Go from moles known to moles unknown. So what's going to be on the bottom? 8. 8 moles Zn. I get this information from the balancing equation. On the top is going to be 8 moles Zn also. ZNS. Why did I not type that? Sorry. And then our last step, what's going to be at the bottom of this fraction? 1 mole ZNS. S, and what's the top's gonna be the molar mass of ZNS? Gonna be right around 97. What? 90 what? 97.45. Thank you, ma'am. Grams ZN. And I only needed 2 decimals there because ZN only had 2 decimals. So I didn't cancel. I'm gonna go back and cancel all my stuff. And answer is 37.2. No, 26? 37.26? No, that's only if it's exactly 5. So 37.3. 37.3 grams ZNS. Now I'm ready to do my other problem, aren't I? So 30.0 grams. Grams S8 over 1 times molar mass of SH, what, 256? 528 grams S8. Oh. And then on the top will be 1 mole. What? I didn't need to, I needed 3 decimals. Yeah, because S is 32.066. I would take it if you put 256.532. I understand what you're doing there too, okay? Does that make sense? Are you with me? Okay, we'll talk about this later. S8, man. And then multiply. What's going to be the bottom of this next one? What's going to be the bottom of this next one? 1 mole S8. And the top is going to be 8 mole because now from here on out, we're all the same. The top would be 8 mole ZNS. And then I'm going to multiply. Bottom be 1 mole ZNS. And the top be 97.45 grams ZNS. So what's my calculation? What's my answer? 91.2. That equals 91.2 grams ZNS. So I answered B, didn't I? What's the answer to B? The answer to B is 37.3 grams. Because the answer to B is 37.3 grams because what gave me is the smallest number. Now, what about A? What's the answer to A? ZN. Why? It's what gave you the least number. So it would be ZN. Any questions about what we've done today? Okay. We're going to build off of this probably on Friday. Okay. We'll build off this on Friday. But if you have a Google Forms, make sure you put your answers in Google Forms. And I didn't put that on there, but make sure that you attach a picture of your work to the assignment, okay? Attach a picture of your work to the assignment. I don't really know. I think maybe 5. It's more than 5.